Hello, students. In this video, we're going to talk about ion formation and the charges of ions and how they get those charges. So the first thing I want to talk about is ions are based, or the charge rather, is based on the number of electrons. So when we gain or lose electrons, we're going to end up resulting in a charge. So the first thing I want to mention is atoms. So basically, atoms are the singular of elements. If I took pure copper, like a copper bar, and I broke the copper bar, which is just a bunch of elements, it's just, the copper is an element, it's just a bunch of atoms lined up. The singular to the plural of element, the singular is atom. Atoms are neutral, okay? Ions have a charge. So an example, lithium. It has the atomic number 3, which means it has 3 protons. So the atom of lithium also has 3 electrons. Okay? Now, it would be the same thing for chlorine. Chlorine has 17 protons and it has 17 electrons. In both these examples, those are neutral atoms. Now, if I had lithium, but I only had 2 electrons, to be lithium, it's still 3 protons. Well, 3 minus the 2 electrons, that would give me an ion because there's more protons than electrons. So 3 positives, 2 negatives gives me a +1 charge. Just like if I had chlorine and I had 17 protons, but 18 electrons. So now I have 1 more negative charge than positive. Now the chlorine is no longer neutral. It actually has a negative charge. So it's the gaining or losing of electrons that determines the charge in an ion. And remember, in previous videos, I said that all of these elements want to be a noble gas. They want to have that octet in their outer shell, their valence shell. So how do we figure out an ion charge? We take the number of protons, subtract the number of electrons. So in this example of lithium, 3 minus 2, right? 3 protons, 2 electrons. That's a +1. In this example of the chloride ion, right? 17 protons minus 18. Well, 17 minus 18 is a -1. That's why we get the -1 charge. Now, ions with a positive charge have a special name. They're called cations. And the way you can remember it, cat, is they have a paw, like in a cat, positive charge. I know that's really cheesy, but it helps me. So cat ions have a positive charge. Now, why do cations have a positive charge? That's because there's more protons than electrons. What does that mean? They lost electrons. So when I lose electrons, when I lose negativity, right? So electrons are negative. When I lose negativity, I become positive. And positive is a cation. We're going to see that metals, and I'm going to explain why, metals tend to form positive charges. Metals lose electrons. Now, if the anion or the ion has a negative charge, it's an anion. I'm sorry, I don't have a cheesy way to remember that. Just remember you have 2 choices, cations and anions. Cations are positive. So then anions must be negative. And why are they negative? Instead of losing electrons, they gain electrons. So what does that mean? If you gain electrons, you're more electrons. If you have more negativity, more electrons, you're negative. So who tends to do that? Non-metals tend to form negative anions. So that's why the organization of the periodic table was so important, right? So when we look at the periodic table, right, there was that little staircase. Everything to the left of it was a metal, obviously except hydrogen, and everything to the right was a non-metal. So now we know that metals, which are to the left, are going to form positive charges, and non-metals to the right of that staircase are going to form negative charges. So when we talk about ions, we have to understand that they're very different than their neutral atoms. So an example, sodium as an ion, as an atom. The sodium, which is neutral, 11 protons, 11 electrons, right? This is an extremely, reactive metal, group 1A. Alkali metals are extremely reactive, right? So it's a metal, right, that exposed to air, it oxidizes immediately. If you throw it in water, it'll explode, right? You take chlorine, right? 17 protons, 17 electrons, right? Chlorine is a brown, noxious gas that'll kill you. But what happens is sodium, if you look on a periodic table, is in group 1A, which represents the number of valence electrons in its group, period 3A. So sodium, the first 2 out of the 17 electrons are in the first energy level. The next 8 are in the second. And then in the third, that's why it's in the third row, the third period. Whoops, I wrote a 3. In the third energy level, it has 1 valence electron, right? Because 2 plus 8 plus 1 is 11. So in that third period, it's in the first group, group 1A, it has 1 valence electron. Sodium gets rid of that 1 electron. And the way they write it is they go sodium, right? And then, whoops, sodium, and then 1 electron plus the sodium ion. That's because I go from 11 protons and 11 electrons. And if I lose 1 electron, now I have 11 protons and 10 electrons. 11 minus 10 equals a plus 1. That's why sodium forms a plus 1 charge. And the reason why it does that is this, we're going to see that this outer electron is lost. But if I take sodium that has a plus charge as an ion, and now with chlorine, right, if we look at chlorine, again, it wants to be like a noble gas. And if you look, chlorine is right next to, who's chlorine next to on the periodic table? If you look at your periodic table, who's chlorine next to? Chlorine is next to argon. So chlorine has 17 protons, 17 electrons. So it has 2 in the first, 8 in the second, 2 plus 8 is 10, and it has 7 more electrons. The next 7 go in the third shell. That's why if you look on a periodic table, chlorine's in the third row, the third period, and it's group 7A. And why is it group 7A? Why is it in the 7A column? Because it has 7 valence electrons. Well, it's right next to who? Argon. It wants 1 more electron to be like argon. So what does it do? Chlorine, 17 protons, 17 electrons. If I add 1 electron, I'm going to get 17 protons and 18 electrons. Well, if we follow what we said up here earlier to figure out the charge, number of protons minus 11, what's 17 minus 18? Oh, it's negative. Well, conventionally, you don't write it that way. You write the number first, then the charge. It's a 1 negative. So chlorine becomes the chloride ion. So Why am I writing this all out? This is kind of a precursor to what we're doing in this whole video, right? We basically have sodium losing an electron, but it can't just throw that electron away. So it has to give it to somebody. So sodium, by forming this positive sodium ion, gives an electron to chlorine, who ends up forming a negatively charged anion. And because this is a +1 and this is a -1, it forms a 1-to-1 ratio. So sodium chloride, right, is basically a sodium ion and a chlorine, which becomes an ion, chloride ion. So I take a explosive metal and a brown noxious gas, and when they exchange electrons, now they're very different from their neutral atom. And how do I know that? Because you sprinkle this all over your delicious French fries. So that's what we're going to talk about. We're going to show you how to figure this out. So here's a periodic table. Group 1A, right? What does that mean? All of these elements have one valence electron, right? So I could look at lithium, right? It's got 3 protons. What does it mean? It has 3 electrons. Where do the first 2 go? First shell. How do I know? Because the first period only fits 2. So it has 1 more electron. Where is that 1 more electron going to go? It's going to go in the second shell. So its outer shell, the second shell, how do I know? Because it's in period 2, has 1 valence electron in it. That's why it's in group 1A. Well, what about sodium? Sodium has 11 electrons. Where do the first 2 go? First shell. How come? 1, 2. Where do the next 8 go? Second shell. 1, 2, 3, 4, 5, 6, 7, 8. 2 plus 8 is 10. Where does the last electron, the 11th electron, go? The outer shell, which is what? The valence shell. That's what determines the reactivity of sodium. And the valence shell in sodium has 1 valence electron, just like lithium. That's why they're in group 1A. So guess what group 2A has? 2 valence electrons. That's why they're all grouped up together. What do you think 3A has? 3 valence. 4A, I guess that makes sense. So what ends up happening? Well, now we have our metals. And I said metals like to do what? Lose electrons and form positive cations. They all have positive charges. Why? Well, here's lithium. It wants to be one of the noble gases. So it has 2 choices. Could be like helium, could be like neon. Okay? So to be like helium, it only needs 2 electrons. To be like in its second shell, okay? Or first shell, rather, sorry. It needs 2 electrons in its first shell. It's in its second shell, okay? So it could lose that 1 electron, right? Lose this electron, give it away, and then it would have only 2 electrons. So it would have 3 protons and 2 electrons. So that would give me a positive charge. Or it has a choice. It could try to gain, right? It has 1 valence electron. What does it want to be? It wants to be like a noble gas, which has 8. So it could try to gain 1, 2, 3, 4, 5, 6, 7 more to be like neon. So it's a lot easier, instead of gaining 1, 2, 3, 4, 5, 6, 7, it's a lot easier to lose 1 than gain 7. So that's what lithium does. Same with sodium. Could try to be like argon, but it would have to gain how many? 1, 2, 3, 4, 5, 6, 7 electrons. It would have to steal 7 electrons, or instead of stealing 7, it could just lose 1 and be like neon, right? Because sodium has 2 in the first shell, 8 in the second, and 1 in the third. How do I know that? Period 1, period 2, period 3. So it has 3 shells. It's in group 1A because it has 1 valence electron. If I get rid of this 1 electron, right, who am I like? Neon, because neon has 10 electrons, 2 in the first shell, 8 in the second. So what's easier? It's easier for sodium to lose 1 than gain 7. So when I go to something like magnesium, right? Magnesium has the same choice. It wants to be a noble gas. So it could be like argon or neon. So if it wants to be like argon, it would have to gain 1, 2, 3, 4, 5, 6, because it has 2 valence electrons. Or instead, it could lose 1, and then they would come over here, 2, and be like neon. Well, it's easier to lose 2 than gain 6. So what does magnesium do? Magnesium, which has 12 protons and 12 electrons, loses 2 electrons to form a 2+ magnesium cation. So for metals, because they don't have a lot of valence electrons. How come? They have 1 valence electron, group 1A, 2 valence electrons, group 2A, 3 valence electrons, 3A. It's easier to lose 3 than to gain 1, 2, 3, 4, 5. So metals that have few valence electrons lose electrons and become positive, and that's why they're cations. Now, nonmetals are the opposite, and this is why halogens are so reactive. So group 7A, they only need to gain 1 electron to be a noble gas. So if you gain 1 electron, so chlorine has 17 protons, 17 electrons. If I gain 1 electron, now chlorine has 17 protons and 18 electrons. Well, 17 minus 18 gives me a ion with a -1 charge. So it's much easier for chlorine to gain 1 electron than to lose what it would, whoops, sorry about that. It would have to lose 1, 2, 3, 4, 5, 6, 7, group 7A, 7 valence electrons. It would have to lose 7 valence electrons to be like neon, or it could just take 1 and be like argon. So what do nonmetals do? Nonmetals gain electrons and form a negative charge, and we call those anions. So a lot of people say, well, where would chlorine get an electron? Who's going to be willing to lose an electron? We just said it. Sodium. Sodium wants to lose it, so chlorine's willing to gain it. So the formation of the sodium ion is based on what we just said. If I have 11 positives and 11 negatives, and I lose an electron, now I have 10 electrons, and I form a plus charge because 11 protons minus 10 gives me a positive charge. Now, this single dot is to show, it's called a Lewis dot symbol, to show that it has 1 valence electron. That's why it's in group 1A, right? So earlier I had written, sodium has 2 plus 8 is 10, plus 1, 11 electrons. It has 1 electron in the third energy level. That's why it's in period 3. It has 1 valence electron. That's why it's in group 1, right? So it's easier for me to lose 1 and be like neon than try to gain 1, 2, 3, 4, 5, 6, 7 and be like argon. So that's what it does. So the sodium ion loses this one, the dot represents 1 electron and becomes a positive charge. Now this, what we haven't talked about, it's called electron configuration. The 1s2 represents what's called the sublevels, And really, you could put helium over here, and this first two positions represent what's called the S block, and then this next 6 positions would be called my P block. So the 1s2 for the sodium is because the first 2 electrons, 1 and 2, go into what's called the first energy level, in an S sublevel. The 2s2, 2p6 this is my S block, my first position of the S block, and my second position. So the next 2 go there, and the next 6 go into the P block of the second energy level. So there's 1, 2, 3, 4, 5, 6 electrons in that P block. And we see, like in the first energy level, there's 2 electrons in the S blocks. In the second energy level, there's 2 plus 6 electrons. The S block, which is 2 positions, and the P block, which is 6, but 2 plus 6 makes that 8 valence electron, or 8 electrons, that octet that we've been talking about. And then in the outer shell, it's a 3s1. Why 1? Because there's 1 valence electron in the third energy level, that's where the 3 is, and it's 1 electron in the S block. This video is not really supposed to be about electron configurations. We're going to get to that later. If you don't fully understand it, don't worry. There's videos to follow to explain that. But I'm just kind of talking about that. So the 1 valence electron in the third energy level, S1, we lose it. And now I have my octet, and my inner shell, the first shell, is filled, and so is my second shell with an octet. What about magnesium? Magnesium has 12 protons, 12 electrons. Why does it have 2 dots? Because it's in group 2A, and it has 2 valence electrons. Where are the 2 valence electrons? Well, these are inside. That's my first energy level, 2. The 2 plus 6 is the second energy level, which I said was 8. And I can count that by reading across period 2. 1, 2, 3, 4, 5, 6, 7, 8. And then the third energy level has another 2. That's where I get this S2. And that's why it's in the second 2A group. Well, if I have 2 valence electrons, is it easier to lose the 2 electrons, like I do here, or gain 1, 2, 3, 4, 5, 6? It's easier to lose 2. So it loses its 2, and now I still have the 12 protons, but only 10 electrons. And the 10 electrons, right? So 12 minus 10 gives me a 2 plus charge. So the magnesium ion now has 2 electrons in the first shell and 8 in the second, because 2 plus 6 is 8. What about the chloride ion? Chloride's a little bit different, right? So here's chlorine. It's got 17 protons, 17 electrons. But what does it want? It wants 1 more. Why are there 7 dots? Because it's in group 7A, and it has 7 valence electrons. How do I know it has 7 valence electrons? Well, chlorine has 17 electrons, right? Where do the first 2 go? In the first shell. There you go. Where do the next 8 go? In the second shell. 2 plus 6 is 8. You can just count it, right? So first shell, 1, 2, and then second shell, 1, 2, 3, 4, 5, 6, 7, 8. So then in the third shell, right, how many electrons are in the third shell for chlorine? Well, there's 17 total electrons. 2 plus 8 is 10. I have 7 more. And I can count in my third shell for chlorine, there's 1, 2, 3, 4, 5, 6, 7. That's why it's in group 7A in the second shell. And they show that because 2 plus 5 is 7. But I want to be like a noble gas. So do I want to lose 7 or just add 1 to it? I want to add 1. So if I add 1 electron, we'll make it a dot. Maybe sodium gave it up. Now I have 8 electrons in that outer shell like argon does. I have 1, 2, 3, 4, 5, 6, 7, 8 electrons or 8 dots. And I look in here, 17 protons minus 18 electrons gives me a -1, but conventionally we'll write it like that. That's why your chloride ion's written like this. And I see, right, in my third shell, 2 plus 6, right, because I added 1 to this, equals 8, and that's my octet. So with ionic formulas, we got to realize that we have positive charges and negative charges, but the overall compound is going to be neutral. So you have to have the charges balance. The positive and the negatives have to equal each other, right? So if sodium forms, because it's in group 1A, a +1 charge, and chlorine forms the chloride ion, it's group 7A, one away from the noble gases. So it's easier to gain 1 electron and be like argon than lose 7 and be like neon. When I look, the charges have to be balanced in the formula, +1, -1. If I kind of crisscross these, I get what's sodium chloride. And that would be the formula for the compound, the ionic compound of sodium chloride. And it's ionic because there's charges, there's ions, and the metals are positive and the non-metals are negative. And we want to make sure that these ratios make it overall a neutral compound. So here's an example using the dot symbol. Why is there 1 dot on sodium? It has 1 valence electron. How do I know that? Going back, 2, 8, 1. Why does it have 11 electrons? Because sodium has 11 protons, right? Why is it in group 1A and in period 3? Because in the third energy level, its valence shell, it has 1 electron. So that's why there's 1 dot. What about the chloride ion? Why does it have 7 dots? Well, that's because it's in group 7A, and it's also in period 3. So you could think of it as, out of the 17 electrons, it has 2, 8, and 7 in its valence shell, the third energy level. That's why it's in period 3 under group 7A. But sodium is willing to lose this so that it has an octet in its second shell and to be like neon, because it's easier to lose 1 than gain 7. Chloride's willing to take it because it only needs 1 more to be like argon, and it's easier to gain 1, especially if you're next to sodium, than to lose 7. So the 1 electron goes in here. There's that extra electron. Now I have a negative charge. Now what we also notice is that the sodium atom is much bigger than the cation. Why is that? Because it loses that third energy level, that valence shell. And the chlorine atom is much smaller than the chloride anion. Why is that? Well, it doesn't lose a shell because that extra electron goes in that third shell. But now, for chlorine, as an ion, I have 17 protons pulling on 18 electrons. There's more electrons than protons. So the protons kind of lose the grip because they're outnumbered, and it spreads out the chlorine's ions in the, or electrons in the outer shell further away. So that's why in sodium chloride, we can use the dot symbols, or we can just use this formula to represent the balanced neutral compound formula for the ions based on their charges. So the sodium loses its valence electron, the chloride gains an electron. And the symbols, right, of the metal is always written first, followed by the non-metal. So that was quite a bit. We're going to still use these terms. We're going to continue with the electron configurations. That was the S block and the P block, and writing sodium instead of just 2, 8, and 1, where we were going 1s2, 2s2, 2p6, 3s1, and that will be in the next videos. But I hope that makes sense. So thanks for tuning in, and I will talk to you next time.